So it looks as though part of our 2.6 did not make it onto the page like it was supposed to. So let's do it again. So for 2.6, we also need to talk about symmetry and even and odd functions. Alright, so what does symmetry mean? Well, the definition that is most common, it's informal as well, is that when you fold everything, when you fold everything matches up. Alright. Some examples of things that are symmetric is a butterfly. Those, let's see, the square, the circle, and so on and so forth. Alright, so let's look at some graphs. Alright, for each of these we're going to say that in the first quadrant we have this graph with a point on it, xy. Now, let's say that we're symmetric after rotating over the y-axis. Then in the second quadrant, we're going to have a matching line and a point for it to fold onto, which would be negative xy. Alright? So this is y-axis symmetry. Okay. So now let's say that same line in the first quadrant, but now let's say that we're going to flip it over the x-axis. And we'll have this shape here, and its matching point would be x negative y. This is called x-axis symmetry. You may think there's nothing else that we can flip it over, but we can do it twice instead. So we'll start in the first quadrant, xy, and then we can flip it over the y-axis, and then again over the x-axis. And it'll be in the third quadrant with the point negative x, negative y. Alright, this is called symmetric about the origin. If you take a look at these three graphs, you'll notice that one of them is not a function. Y-axis symmetry results in a function. Symmetric about the origin results in a function. But x-axis symmetry, just by definition, is not a function. Alright, if we look at y-axis symmetry, it kind of looks like y equals x squared. And so we call these even functions. And the symmetric about the origin looks kind of like x cubed. We call this odd functions. Alright, so look at these a little bit further. Okay, so we notice that for an even function, we have a point xy is matched with negative xy. Alright, well, if we use our function notation, this says that f of x is equal to y. What else is equal to y? Well, that would be f of negative x. Okay. For an odd function, we have xy is mapped onto negative x, negative y. So we can look at kind of the same things. Notice we have f of x is equal to y, and we have f of negative x is equal to negative y. Well, that y has already been defined as f of x, so we have f of negative x is equal to negative f of x. Alright, so what does all this symbology mean? Well, basically, if you'd notice, they both have plugged in negative x. So the way that we test to see if a function is even or odd is we plug in a negative x and see what happens. So for our example, let's do f of x is equal to x times the square root of x squared plus 1. Alright, so we said we're going to plug in a negative x, so f of negative x is equal to negative x times the square root of negative x squared plus 1. Alright, so this negative on the outside is the power of 1, so that means nothing happens to the negative, so negative x square root negative x squared. Well, negative 1 squared is positive 1, so this is x squared plus 1. Alright, let's see. So this isn't equal to what we started with. That means that it's not even. But notice it's equal to negative, in parentheses, x square root of x squared plus 1. And this is equal to negative of what we started with. So that means that this is odd. If neither one of these happen, then it would be neither. All right?